All right, here are 5 quadratic functions, all written in standard form. And what I want you to do right now is determine the a, b, and c values for each of these functions. And then what I want you to do is tell me what you know about the parabola given the a value. What does that tell you about the parabola? And the c value, what does that tell you about the parabola? Okay, if you need to pause the video, pause it now. All right, so for the first function, you should have got the a value is 1. Remember, there's no number in front of the x squared. That means it's 1. B value is -6. C value is -5. All right, what does a value being 1 mean? Well, it means it opens up and there's no dilation. And then the c value being -5 tells us the y-intercept is 0, -5. For the second one there, we had y equals -x squared minus 2x plus 8. All right, so the a value is -1, the b value is -2, and the c value is 8. So the a value tells us it opens down because it's negative. There's no dilation because the absolute value of -1 is 1, no dilation. And the y-intercept is the c value, so it's 0, 8. All right, for the next one, our a value is 0.5, or you might say 1/2. Our b value is -6, and our c value is 3. So the 0.5, it's positive, so it tells us it opens up. It does have a dilation. It's a vertical compression, so it's going to be a wider or fatter parabola. And the c value is 3, tells us that the y-intercept is 0, 3. All right, for the fourth function here, y equals 2x squared plus 4x minus 9. Our a value is 2. Our b value is 4, and our c value is -9. So the a value is positive, so it opens up. It's 2, that's greater than 1, so that means it has a dilation, and it's a vertical stretch. Our c value is -9, therefore the y-intercept is 0, -9. For number 5, or the black equation here, we have y equals -3x squared minus 9x plus 13. So our a value is -3, our b value is -9, our c value is positive 13. The a value being negative tells us it opens down. The fact that it's a 3 tells us the dilation, it's a vertical stretch. And then c being 13 tells us the y-intercept is 0, 13. Let's take a quick look at the graphs we did in Desmos just to see if our predictions were correct. And you can see it on the graph, right? The 0, -0.5, that is the y-intercept. You notice that we can't see the vertex in standard form. See how the vertex is 3, -14? Yesterday, we were able to see the vertex in vertex form, right? But now we're dealing with standard form. We cannot see the vertex here. All right, so the next example, were we correct? Yeah, you see the 0, 8, there's our y-intercept. It does open down. There's no stretch or compression. And we can see that the vertex is -1, 9, which again, we cannot see that in our equation. The third one, this one, it's a little bit hard to tell in Desmos here the way I have it scaled, but this one is compressed. So it's a little bit wider than the parent graph. And we can see that 0, 3 is the y-intercept. Again, the vertex 6, -15. Can't see anything in the equation. It's going to tell us that that's the vertex. It's just not there. Can't see anything here that tells us a line of symmetry right off the bat, at least from what we're learning today. All right, soon we'll have a way to use the a and the b value to quickly determine the axis of symmetry. But stay tuned for that. All right, part 4. Yep, we can see it opens up. It is a vertical stretch. It is skinnier. It does cross at 0, -9 is the vertex, or I'm sorry, is the y-intercept. And our vertex, which we can't see in the equation, is -1, -11. All right, and then our last one, we can see that it definitely opens down. It is stretched, much skinnier. We see our y-intercept at 0, 13. And then look at our funky vertex. We have -1.5, 19.75 as our vertex, which again, we cannot see that in this equation at all. All right. At the end of today's lesson, I'm actually going to have you rewrite these 5 equations I gave you in standard form. I'm going to give you the equation and the graph here again. I'm going to ask you to write those in vertex form. All right, just look at the next ones here. I gave you the exact same equations, but except for I set b equal to 0 on all these. So you notice that it's just going to be y equals x squared minus 5, y equals negative x squared plus 8, y equals 0.5 x squared plus 3, and so on. So these are the same equation, except now they don't have x to the first degree. It's the only difference. So everything else stay the same. Your a value is the same, your c value is the same. So the opening up or the dilation factor, the y-intercept factor is all exactly the same. So now, what do we know when I give you this way without a b value? B is 0. What do we know about the axis of symmetry? That's right. The axis of symmetry is on the y-axis. All right, let's ask the question again then. What do you know about the vertex when I give you the equation like this in standard form where b equals 0? That's right. The vertex is on the y-axis because we know the vertex is always on the axis of symmetry. So here's the graphs. I just put them all in one graph here, but you can clearly see all the different graphs, and you can see that their vertex is also the y-intercept in this case. So this is a special situation. When the b value is 0, we know that the axis of symmetry is on the y-axis and the vertex is on the y-axis, and it happens to be the same point as the y-intercept, right? So 0, 13 here, 0, 13, that is the y-intercept for this parabola, but it's also the vertex. Okay, so this is a special situation I want you to be aware of. All right, I did all those examples for you, but a lot of you may want to still play with this a little bit, or you might be still feeling a little iffy. My recommendation is go to desmos.com, enter y equals x squared as the parent graph, and then I want you to put in a bunch of different a values. You know, y equals negative 1x squared, y equals negative 1.5x squared, y equals 6x squared. What does that do to the graph? Then change your c values around. Go y equals x squared plus 7, y equals x squared minus 11, y equals x squared plus 18. Okay. Then if you want to get real creative, change your a value and change your c value. And then for the fun at the very end, if you want to add a b value in there and have something like y equals negative 3x squared minus 6x plus 14, go for it. But I want you to be really paying attention to the a value and the c value and how they affect the parabola today.